let's solve a trigonometric equation with inverse trig functions using a sum identity. So we're going to solve the inverse cosine of x minus the inverse of sine of x equals pi. This has some steps and a little bit of confusion in, so listen carefully and let's work through it. Our first step is going to be to isolate a trig function. And I want life to be as easy as possible, and I want things to be positive when possible. So we're going to add the inverse of sine of x. So I'm going to have the inverse of cosine equals the inverse of sine of x plus pi. Now, when we're thinking about what quadrant are we playing in, all right, so let's think through this. And I'm going to go to a new page to think through this one, okay? The range of the inverse cosine is 0 to pi. So we have pi plus the inverse sine. That's what equals our inverse cosine, and that has to be between 0 and pi. Well, if we subtract pi from both sides, we get negative pi inverse sine of x to 0. All right. Now that means we are going to be dealing with the bottom yonder, right? So we are actually going to be playing in Q4. From 0 to negative pi is these directions here. So we are, in fact, because we're dealing with where is sine negative, that's both down here, and cosine is positive, because our cosine is positive in quadrant 4. So that is why we are located in quadrant 4, because sine is negative there and cosine is positive. Okay, so Q4 is where we want to be. Now that's important because we are thinking about our angle. If we go back to our inverse sine of x. So that means that the sine of some angle is x over 1. So if our angle is here, this is our theta, then sine is opposite over hypotenuse. Well, we can use our Pythagorean theorem to find our missing value, and that's going to be the square root of 1 minus x squared. That's important because when we look at this and say, okay, we are ready to continue solving our problem. Well, on our left side, we want to get x by itself. So x equals the cosine, because remember, you inverse both sides. So cosine of the inverse sine of x plus pi. Now I have the cosine of a sum. So I go to my trig identity page, and I say, okay, the cosine of a sum tells me that I will have the cosine, oh man, I wrote this backwards on my paper, but that's fine. I have the cosine of the inverse sine times the cosine of pi minus the sine of the inverse sine. I forgot my x in the first one, times the sine of pi. Okay, this first piece right here, this cosine, inverse sine of x, but I need the cosine of that. So if I go back to this and I say, okay, so here's our theta. I know that the sine was x over 1, so that's going to make the cosine the square root of 1 minus x squared over 1. So the sine of that, again, is the square root of 1 minus x squared times the cosine of pi. And what is the cosine of pi? Negative 1. Okay, now I'm going to subtract. When I have the sine of the inverse sine, that leaves me with just x. And the sine of pi, well, what is the sine of pi? That's 0. Oh man, did life just get easier? Yes, yes it did. Because what's 0 times x? 0. And I am left with x equals negative the square root of 1 minus x squared. Okay, so far, so good. I'm going to go to a new page so that we have more room. So x equals negative square root 1 minus x squared. Now you can do this a couple of different ways. I am a creature of habit and I say, okay, well, before I square both sides, I just want to get rid of this negative. I don't know why, but this is how my brain works. It's a curse and a blessing, I suppose. So now that I've isolated the radical, I can square both sides. So I've got 1 minus x squared on the right, and I have x squared on the left. If I add an x squared to both sides to get my x's together, I get 2x squared equals 1, divide both sides by 2, and I square root both sides. So x equals 1 over the square root of 2. I need to rationalize my denominator, and so x equals radical 2 over 2. Now, before I think too much about this, remember, we are in quadrant 4. Well, x is positive, y is negative. That does need to be a negative value. So x is negative radical 2 over 2, because what is x? X is an angle. We are dealing with angles. And so we are going to have a negative radical 2 over 2. Doop, doop.